Okay, next we have Shyam Sankar of Palantir Technologies.
Thanks, Melody. So for those of you who had a social life in high school, which would not be me, a Palantir is actually a seeing stone from the Lord of the Rings stories. And with the Palantir, you could actually see what was going on anywhere in the world through this sort of crystal ball, let's call it. In fact, part of the meme that Tolkien was playing on was the crystal ball meme. And at Palantir Technologies, we make a platform that allows your average human to interact with very large, disparate data sets in intuitive and conceptually simple ways. So your average human, not your average engineer. And so it's the democratization of access to this information. It's hopefully the equivalent of a technical seeing stone. And so I wanted to talk a little bit, my stories will be a little more anecdote-based about how we stumbled into collective intelligence. And we really did, as a company, stumble into it. And to understand the origin of this, we have to go back to where Palantir came from. And so Palantir was actually founded by the same folks that founded PayPal. And if you think PayPal, this is the online payments company, if you think about PayPal as a business, it's not particularly difficult to build a website that sends money back between people online. But it is particularly difficult to do that without being defrauded by the Russian mob. Now, that is the existential threat. That's the challenge in the PayPal business. If you can do that, you have a real business. And many people tried and failed. And the issue is that if you're a computer scientist approaching the problem, the first thing you're going to try to do is to build a classifier. Use machine learning, artificial intelligence to find a way of automatically classifying transactions as fraudulent or not fraudulent. And this is going to scale really well, because when you're doing 1 million transactions a day, you need something that scales really well, even at that point in time. But the problem is this doesn't really work when you have an adaptive adversary. And that's certainly the case with the Russian mob. It's certainly the case with terrorists and cyber criminals and the whole lot that we're interested in thwarting. But what does work really well is humans. And the way that PayPal discovered this was out of complete desperation and luck. So you're hemorrhaging cash, which I'll talk about a little more later. And what are you going to do? If machine learning's failing you, well, you basically tell everyone in the company, go look at these transactions and try to figure out what's fraudulent and stop it if you can stop it. And much to their surprise, the humans were very good at deciding or classifying what was fraudulent and what was not fraudulent. They were terrible at doing this at scale. And so then they started asking themselves very tactically, how do we fix this problem? How can we get a little bit more scale? How can we get a little bit more runway for the company? And what they realized were there were a number of discrete things that were stopping people from interacting with this data at scale. So humans are particularly bad at integrating large and even very, very small disparate data sets. So when you have different formats, different structures, different sort of conceptual, let's call ontologies or data models that underlie this, humans are terrible at dealing with that. Turns out computers are very good at dealing with that. Humans are terrible at taking the knowledge they've learned and disseminating it or putting it in a format that essentially other people can quickly build upon it. Turns out computers are pretty good at doing it. So similar, there were all these tactical issues that computers were very good at dealing with. And there's actually a formalism to this approach. It's called intelligence augmentation, something that we certainly didn't know about at the time. But you can almost define this in contrast or in opposition to artificial intelligence, where with AI, you're really looking for a solution you're looking for the computer to make a decision to help the person. In the IA, or intelligence augmentation approach, you're looking to create a technical solution that helps humans make better decisions. And so this is what we actually do, intelligence augmentation. But it sort of presupposes, or it's one level down the stack of an emergent collective intelligence. And so what emerged out of this system at PayPal, where you had lots of analysts looking at transactions across a very large disparate data set, well, you had humans who were working together in a system that was designed to leverage the power of human intelligence. And I'll say that's even a slightly worse definition than collective intelligence that we had earlier. So there's two anecdotes that I wanted to go through about what we learned in trying to build a system that essentially would allow for collective intelligence to emerge. The first is an anecdote from PayPal, where we literally had fraud that was 150% of revenue. So for every dollar that you were making on a transaction, you were paying the Russian mob $1.50. That's not a business. That's yes. So you have to fix this. And what they did was they tried to get everyone possible to contribute to fighting this. And this, of course, led to the fact that there was a diversity of talent that was being applied against the problem. And so prior to this, you had essentially statisticians who were looking at the data, fraud SMEs, and you had maybe someone who happened to be in QA but was a native Russian speaker, and someone who was a high school grad but was very facile with computers, and you kind of combine them together and you started to discover very, very powerful things happening. And so one, at the time of the late 90s, this was certainly against conventional wisdom, but I think more interestingly, it's one thing to understand that there's a possibility for the diversity of talent to contribute to something very powerful intellectually. It's another thing when your entire business is on the line and you really understand that, no, the 10 computer scientists who are fraud experts aren't actually going to solve the problem, but the 100 people who otherwise are a motley crew of linguists and unskilled labor and everything actually will solve the problem. And so that's another revelation that we sort of stumbled upon here, is leveraging the abilities of outsiders. The other issue that we dealt with that had much more to do with the intelligence community and Palantir per se was dealing with incredible amounts of uncertainty in the data that you're looking at. And almost data and intelligence are terrible in the sense that they're not distinct. At some point, because of the way that we as humans think about things, we engage in a very iterative analytic process. All of our thoughts beget maybe 5 other thoughts that are orthogonal in some n-dimensional space, and those beget further thoughts, and ideally there's some sort of construct where the output of my thoughts becomes the input of some other person's thoughts, standing on the shoulders of giants, et cetera. And we found that most software out there presupposed some linear flow to how they wanted analysts to think. And the reason they do this is very simple, is that by introducing this constraint, it's much easier to design software. If you relax this constraint, you have a very unbounded problem, and it becomes very difficult. But the real problem here is that when you have this constraint, because it doesn't map to how we think, and therefore you're not actually going to be able to augment human intelligence, you create this feedback loop that amplifies bias, and that creates tremendous variance in where an organization thinks something is going to go. And the canonical example in recent history of this is curveball. So bad intelligence about weapons of mass destruction, where you had a little kernel of information that just went through this massive feedback cycle and led to huge variance in outcome. And so how do we deal with this? Well, as the sort of motley crew of Silicon Valley computer scientists that we are, we were inspired by the elegance of version control, the semantics that version control bring for software engineers when they're working together on incredibly complex and large projects. And really the idea is that with version control, you have the ability to have lots of concurrent sort of realities. If you think of the code at any one point as a current reality of what could be. And you also have a way for people to understand who's contributing what and how to reconcile the differences in reality. And so that's really the point, is that someone's output can become someone else's input in a way that's quite seamless, even if that's the same person. And that the organization, so not the individual, but yes, certainly the individual, but that's a banality. But the organization has an ability to explore all concurrent, interesting analytic paths concurrently. And that's very high leverage. So this means that you can see not only what is today's thought of where something is going, but what is the dissenting opinion, and how did that vary from yesterday and 3 days before? And then when you go from a dimension where you have only 2 options and you have thousands of what could be and what could not be, what's in the big tail, this becomes very important because you start to see lots of variance in what people believe as new data starts to come in. So many of you may be familiar with a series of work that we've done, but I wanted to focus on 2 case studies in collective intelligence specifically. One that's done and one that we're about to embark on. So the first is Project Grey Goose, which was named after the French vodka, mostly because the person who was organizing it, Jeff Carr, a blogger at Intel Fusion, was going after the Russian hackers that were involved with the Russian-Georgia cyber conflict. And Jeff set out to get a complete volunteer force. To his surprise, he expected maybe 10 people. He got well over 100 submissions. He just stopped counting at that point, for people who wanted to participate in helping to analyze a large amount of disparate data. So from network level data to sort of human information about the hackers themselves. And in this context, Palantir was just simply the platform for all this data to come together in. And then a volunteer force that consisted of some cyber experts from the community, outside the community, people who were Russian language speakers, people who had no specific skill but were interns at sophomores in college who wanted to participate, worked for less than 3 months on a part-time basis to examine this. And the results were so astonishing, I think, for us to see, again, not as a formal Palantir, not as formal devotees to collective intelligence per se, but to finding the best solution, that these 3 months of part-time effort was actually so compelling that it rippled through the IC. So